Good morning, everybody. Happy snow day number 2. For our asynchronous learning today, I decided to make a quick little video. This is the worksheet that's actually posted on Google Classroom for you guys to complete. So I'm going to lead you guys through the proof, number 1 up here. I'll lead you kind of through it, hopefully addressing some maybe questions you might be thinking in your head, as well as reviewing some vocabulary and some of the aspects of the problem that we should be looking for in order to create this proof. So, in this first one, we are given that ABCD is a parallelogram. And obviously that's our first statement. We're going to start with ABCD is a parallelogram. And obviously that's the given. Now the second thing we're going to try to figure out now is, well, how can I come up with that these two triangles are similar? Because that's obviously our goal. We're trying to prove AHE is similar to triangle FHG. So, right off the bat, I don't see any side lengths on this. And the fact that I have a parallelogram, it doesn't really help me with side lengths either. It helps me knowing that I have parallel lines and maybe some of the angle relationships that are inherent in parallel lines. But the point being is I don't have any information about side lengths based on this diagram. So right away, there's only 3 ways to prove that triangles are similar. Side, angle, side, 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 and angle, angle. Well, there's no side lengths. So I'm not going to use SAS or SSS for this one. Therefore, I know my strategy is angle, angle. So I'm going to try to identify 2 congruent angles from this diagram. Well, first thing I can identify is angle EAH. That's this angle right here. Well, that's congruent to another angle in the diagram. See if you can come up with it. You might be able to spot it right away. At home, you might be able to come up with angle GFH. The reason why those 2 angles are congruent to one another is because they are alternate interior angles. Alternate interior angles are an angle relationship that were established through parallel lines. Hence why they told us ABCD was a parallelogram. AB, the top line, and DC, the bottom line, they're parallel to each other. So by having those transversals drawn in, they create alternate interior angles. That's obviously one congruent angle. We need 2. Now I could use alternate interior angles again for like angle G and E. I could use the same logic and do the same step again. I could also use, so there's more than one way of doing this. I could also use the fact that angle AHE is similar. Look at AHE. That's this angle. Put 2 lines on this one. What's AHE similar to? Well, angle AHE is similar to or congruent to FHG. If you notice, that's the same order that the letters are written in the triangle. The corresponding angles, the way it's written in a similarity statement, help us to identify what angles will be congruent. Why are those congruent? Well, those are vertical angles. All vertical angles are congruent. Thus, we've shown that we have 2 congruent angles, and we really could have shown all 3, but we only need to show 2. But we got 2 congruent angles, therefore, triangle AHE got a little sloppy on the triangle there. I almost wrote congruent, so I just crossed it out. Is similar to triangle FHG. And that's by angle, angle similarity. Use the structure in this proof as you guys attempt to tackle the remaining proofs on here. Ask yourself, do I have side lengths? Do I have information about angles? Why would they give me this particular given? Remember, it's just like the UNO activity, meaning they give me a starting card and I can kind of piece it together from there. I know where I have to end. I know where we have to end my proof. So we're going to strategically design this proof to demonstrate similarity, in this case, through angle, angle. Good luck on the rest of the proofs, guys. Message me if you have any questions.